right. Good afternoon, everyone. Welcome to one more serverless session.
Woo!
This one is a little bit different. The other ones, at least me and the rest of the product team have been part of. We've been talking about technology and a lot of it targeted to developers, but we haven't used the true customer cases, how our customers out in the wild are really using serverless technologies to put production solutions together. What are they be able to accomplish? And actually, what are the challenges? Because not everything is maybe as easy as it seems. So I'm Eduardo. I'm PM lead for the Azure-Functions team. I'm here with Thiago and Nick. So actually super happy that Nick is here because he is actually not a Microsoft, he's a customer that uses functions. He never met me before. He picked functions on his own, and he's going to talk about how he adopted serverless, his organization. I'm also happy that Thiago is here, too. I haven't seen him in a while. But one thing, like context that we typically do, Thiago and I work, is a lot of companies are deciding to go to serverless, and they don't know where to start. They have a problem that they want to solve. Microsoft has tons of technologies, and they want to just sort of try things out. And Thiago's team run these things called open hacks, where a customer comes with their scenario. They sit with some of us, the Microsoft product teams and the CSC team, and we code with them. And one thing that's fascinating to see is with serverless technology, we typically schedule for 3 to 5 days, and on the first morning, first day, they have something that's up and running. We see how easy it gets started. And as soon as they have something up and running, because it's serverless, it scales really well. So we love doing those things. Some of the customers we talk about, actually the case I'm going to talk about at the end, highlights what they were able to achieve. They started in one of these open hacks, and now they're in production, and now they're having production worries. They're just emailing us that they're now getting ready for Black Friday, and they're testing scale and things like that. But it was super easy for them to get started, start using serverless. So what we want to do is we're going to go a little bit into, this is a 200 level session, so we're not going to assume everybody knows serverless and the Azure technologies we have. So we're going to do a brief overview on serverless, and then we'll go into the real world scenarios. And there are a bunch of scenarios accomplished with serverless, but these are the ones we think is really popular. One is for IoT events, how you process IoT events using different set of technologies. The other one is when your enterprise requires your infrastructure to be under secure endpoints and security is in your mind, how do you use these technologies? Is it possible? What are the tricks that you have to do? And the last one is serverless sounds great. It's stateless and async and short-lived, but how do you accomplish a much more complicated workflow? So we'll go to each one of these customer scenarios, architecture diagrams. If you like those, there's going to be plenty here. And at the end, we're going to give you a bunch of links that you can use if you haven't started on serverless, or if you're already advanced, for you to be successful with it. With that, Thiago will present the first one.
All right. So who's been to other serverless sessions here at Ignite? OK, so it's not the first time you see these slides. I apologize. Bear with me. The good news is that you're going to get out of here knowing how to present these slides because you've seen them so much. But just as a recap, starting from on-premises, you own everything, and you own all the concerns there as well in the infrastructure. And going into infrastructure as a service as well. Going further, you can see we reduced how much you own and how much we run for you. And then finally, serverless is the evolution on top of platform as a service, where you end up worrying about your code, your logic, and we take care of everything else behind it for you. So that is the history of cloud development, where we started with everything on premises, shared on premises, then go into infrastructure as a service, where we expose VMs and networking for you to run your platform on top of. Finally, we identified some things that make sense to become a platform for you to run on top of. And now with serverless, it's not that there aren't servers, it's just it's taken care of for you, and you don't have to worry or run them as much as you used to. So that's the key difference here. And that's where we're seeing a lot of customers move towards to implement their solutions by running on serverless because they want to worry about their logic and their workflows instead of networking, VMs, all of that. All right, so just a quick recap on what we consider serverless. Three key features of serverless. The abstraction of servers, just like I said, there are servers there, but we're taking care of the infrastructure for you. So it's abstracted from you. The second one is the scalability. We look after auto-scaling out and back in. You'd be surprised with how easy it is to scale out, but not back in for if you try to implement it all yourself. So we take care of both out and in, especially in the real serverless environments that we have, like the consumption plan for logic apps or for functions, and also with logic apps where you just pay per execution, which is the third point here. Every time your code gets executed, that's when you get charged. If there's a month of idleness in your solution, you're not paying for the infrastructure behind the scenes, and that makes a lot of sense from a financial perspective as well. So there's the key three things, and then some benefits that we see customers getting from running serverless. Like I mentioned before, it helps you focus on your business problems, implementing those, and not focusing on infrastructure, the security, and everything else. Of course, you also will still have some concerns and worries about that, but you can ask Eduardo the hard questions there. How is it done for me? And we'll answer those questions for you, but you don't have to implement them. We'll just give you the assurance and pass the certifications that will have covered all those concerns. The next one is efficiency. Given that there's less for you to worry about, it also helps you get to market faster. And like Eduardo was saying, when my team runs hacks with customers where we sit down, code with you for a week, usually by the end of that week, we end up with a really good proof of concept, if not something closer that can get taken to production really quickly. And that is something that comes up more often than not with serverless. And finally, the flexibility. You can use it for experimentation as well. We see a lot of customers that start with serverless, do proof of concepts, and then they realize, oh, I need this behind some very specific scenario, or I need it to scale to something huge. And then you can migrate your code between Azure Functions, Logic Apps to other parts of Azure as well. Like it says there, easier experimentation is a key one. It also plays a pretty good fit for microservices, where you can use Azure Function app as a microservice and all the functions behind it that are related to the same thing, and deploy multiple of those functions to implement multiple microservices that talk to each other using messaging like service bus or storage queues, and then have that bus in between all of your microservices. So as you look into building microservices, there was a separate session that covered microservices using Azure Serverless. So if you haven't seen that one, make sure to check it out. All right. The last one here is just covering what on Azure we consider serverless. Azure Functions, of course, that's the code as a service, the functions as a service. Logic Apps, which is the workflows design as a service. So it's a visual way for you to implement workflows and also connections to the outside world. And then the events between them. One key one, besides the normal messaging like Service Bus and others, is Event Grid, where it manages all the events that can trigger your code or your workflow logic to run. But we kind of see serverless as a platform, and it's usually, there's more to your application than just the serverless components. And that's why we have there quite a few other parts of Azure that you usually take advantage of, like saving data to Azure SQL database or to Cosmos DB for the state of your applications, or Azure Storage if you're passing files around or ingesting files into Azure, analytics, intelligence, and a few others. And we have a really good development story for functions. So if you haven't tried it, get the latest updates for Visual Studio Code and the extensions, or Visual Studio and the latest Azure extensions, and try it out, and you see how easy it is for you to develop applications using VS or VS Code for Azure Functions. All right, so let's get into the actual scenarios that we have. This is the first one. like Eduardo said, there's quite a lot of different things that you can do with serverless on Azure, but this is a pretty key one that we keep working with customers on. And the first one is IoT and processing event streams that are coming into Azure. And the customer that I picked for this is called Glass Smart Thermostat by Johnson Control. They just released a smart home thermostat to the market recently, and it's basically a thermostat unit that is super intelligent, sits in your home and controls your home thermostat, and also communicates to Azure and does the work there. They used to have the whole solution in VMs. They started on premises. They moved to Azure on virtual machines with their own .NET code there running the services. And then they started realizing there's no need for us to do this. Let's start migrating our implementation to Azure Serverless. The intelligence part of this is a clear differentiator, so there's a lot of communication between the thermostat and Azure. They want to be ready for the vertical growth. So like I mentioned, they just came out with it in the market, but they have their expectation for really quick growth in the market, and they want to be ready for it. So that's why that auto scale and pay as you go becomes pretty important for them. They've tested it out with 20,000 IoT devices, besides testing it with real devices as well, of course, and having some online already. And then they noticed that this whole event-driven architecture that they've implemented works really well for IoT. So what does it look like on their side for their architecture? This is a small sample of all of the paths that they have between their JCI devices and Azure. But just to cover some of those, the first one is when you first get your Glass device, you're going to register it. Everything between the device and Azure goes through IoT Hub, because that's basically the messaging infrastructure that also lets you manage IoT devices, right? So it'll know how to talk to IoT devices, and the devices will know how to talk to it. So the messages come from the JCI Glass, go into IoT Hub, sends a registration. That registration ends up in a microservice that they created in Azure-Functions that then saves the data into Cosmos. After that, it then raises an event into Event Grid to alert other systems that they have internally to react to that. So maybe since you registered the device, we need to send an email to the customer to say, hey, congratulations, you finally registered your device. So that top one there is the Event Grid notification to Azure to say, hey, a new device has been registered. The next one from, I guess, again, on-premises to Azure is pairing. So that's a pairing service that will alert their systems that there's been a pairing between the device and Azure now, and it's ready to start working. And finally, if the user goes and updates the settings on the device to say, hey, I need my thermostat to be in between these two regions, that also sends a message to Azure, goes into IoT Hub. IoT Hub forwards it to an event hub that triggers a function. The function not only updates the Cosmos DB database with that information, but it also raises an event into Event Grid. And in this case, they have SignalR in a service that picks up that message from Event Grid and sends it a notification to the person's device, mobile phone as well. So you can see if you're, have your thermostat, you also want to be able to control everything from your phone, from the app that they provide with the device. So that's how it goes. If it goes from the device at your home, sends it to Azure IoT Hub, Event Hub to the function saves the information and also sends it via SignalR to update the user's device. And that might pop up a notification saying, hey, it's now updated to this setting. And the final one, because this is all going from device to Azure, the final one is the other way around, from Azure to the device. And like I mentioned, this is a sampler. They have quite a lot extra going on. But coming from Azure, if the device has this solution to show you what the weather is like locally, if there's an update to the weather for a specific region, that gets raised as an event into Event Grid that then triggers an Azure function. Then Azure function goes and checks a cache to see if it's up to date already for the weather information for the location. Otherwise, it goes to a service that updates the cache. and then sends it back to IoT Hub and to the device. So that's how it keeps all the devices within geolocation up to date with that information. So just a few examples here of the communication that they are doing. One thing to notice that I didn't call out is you can see that there's IoT Hub and then 3 event hubs. And that's how they managed to map specific events to specific functions or specific microservices, is because everything goes into the same IoT Hub, but then it gets split up into 3 or more, quite a few more event hubs that then are specific to a message type. And then we have the function that knows how to handle that message. You could also do this in a function itself. I've seen a few customers do it where it goes into IoT Hub triggers a function, and then in the function you do the if, else, etc., to then map it to other event hubs. But given the IoT Hub gives you that routing mechanism, it makes more sense to do it there. So a few topics there. IoT Hub for the messaging between the cloud and the device. Event hubs, it's both for routing and also throttling so that the functions can catch up with it. Functions they use it as microservices, so each service cares for that specific type of message, like registration. And then they also use SignalR for the messaging back to the devices. Cool. So a few lessons learned that I spoke with the engineers at JCI Glass, and they sent me a few things that are key. They quickly realized that just functions or just logic apps doesn't make sense for a solution. There's quite a lot of things that you compose on Azure with the serverless bits in the middle to implement your full solution. The second one is you can either do a combination of functions and functions with other parts. So if you need if you have quite a lot of telemetry coming in, you can also use things like Kafka or Stream Analytics to identify trends or things that you need to react on based on that data, and then leave functions and logic apps to handle other types of information. Another one is implement logging and telemetry. So IoT Hub will mark the message when it received it. Event Hubs also has in queued time. In your function, make sure that you also, when you pick up a message, enrich it with more information as well of when it got received before you send it on, so that eventually you have that one correlation ID for that event that went through your whole system, and you know where it stopped, and you're also able to re-queue it if you need to and send it back into IoT Hub for reprocessing. And that kind of leads us to the final lesson there, poison queues and dead lettering to deal with the messages that fail. All right, so I'll do a very quick demo here. So here we are inside of Visual Studio. I have an empty Azure Functions project, and I'll just add a new function. Call it Azure Function. You can see here I have IoT Hub as the trigger, and I also have Event Hub as a trigger. So I'll go with IoT Hub. I'll give it a name, and that is the name of the setting for the connection string, not the actual connection string. Click OK there. You can see it gives me a pretty simple IoT Hub trigger device here, or function to react. So finally, I'll go into my local settings file, add that there, and we just need to get the connection string for that IoT Hub. So back here on Azure, I have an IoT Hub pre-created inside of Azure, and it has built-in endpoints. The default one is the events one. So I'll just copy that connection string, which is what we need. And notice that how it says Event Hub compatible. So that's the type of connection string that Azure Functions works with. It's good to keep that in mind. So I'll save this, and I'll start this processor. And that's going to start my function locally here as I'm developing. I have another project here called the Simple Device Simulator. And this is basically a project that we created ourselves in our team to start sending messages to IoT Hub. So it's going to create 5 devices of each type, one for fridges and one for light bulbs, and starts pumping that data into that same IoT Hub. So as I trigger that IoT hub, it's registering 5 devices of each, and it's going to start sending the events into Azure for that IoT hub. And then my function here, it's starting picking those up and processing them. Pretty straightforward, pretty easy to implement, right? The other thing that I wanted to show you is I also have another resource group here with a more advanced scenario where I have an IoT hub, an event hub with two, namespace with 2 event hubs in it, fridge and light bulb. And then in that IoT hub, let me go back into it, I have message routing set up. So it's kind of peeking into the message and saying if the device type is light bulb, forward it to that event hub. If the device type is fridge, forward to the other event hub. And that's the same, similar thing that the JCI Glass team did. They are looking into the message and splitting it out to the service. The other thing that I have in here too is 4 Azure container instances with some code that we wrote to really test this out. And it's going to start pumping events into Azure at a higher rate than I can do just from my local VM. So that's the code there for it. It's basically just sending it straight into Event Hub for both these light bulbs and the fridge. And then here I create a bunch of container instances to send that telemetry in. We've also done it with logic, Azure durable functions and spawning multiple activity functions to send the data in. There's a few ways to do it. Also, another way is to use Service Fabric and really scale it out to send massive amounts of data into Azure. But this is a fun way to do it, just creating containers instances, getting it to run. And the thing that I have here is to just start it. And the application that I'm using is called Locust. It's an open source project for you to just hammer things with HTTP calls. And I'll just go into here and start the clients. And that's basically going to start the 4 clients that I have on Azure. I can go into one of them for us to check it out. So that's starting a few users, sending requests per second into Azure. And that's going into IoT, the 2 event hubs that I have. This function is, there's 2 functions in my function app that are looking at those 2 event hubs. And then it's going to start processing all of those messages. And the final thing that I want to show you here is the application insights for this function as it starts to load. Let me refresh that. I think I left it open for a little too long. All right. And one quick way to see it is the live stream of the metrics. And by default now, when you create a new function, it'll create the telemetry, the App Insights endpoint for you. And you can see it's already processing 50 messages a second. And over time, it's going to start scaling up and up and up and adding servers. Like we said, it's not that there aren't servers. We're just taking care of it for you. And as you can see up there, I have 1 server online now handling those 50 messages a second coming in with 500 output, because I'm batching the receive. So one function execution is getting multiple events from Event Hub and then processing those. So this is an easy way to see 50 a second with 500 going out. Those exceptions they show up because it's adding servers, so it's just working out the lease logs about Event Hub. Is not a real exception. You can see it's already scaling up to 2 servers, and it's going to keep scaling up until however many it needs to process the events that are going into your Event Hub. All right, so that's all I had for this demo. Pretty simple way to show this scenario here, where you have an IoT hub with multiple event hubs with functions behind the scenes processing the events that are going into those 2 hubs. Cool. So with that, let me switch over to Nick. Thank you.
All right. So my name's Nick Lazat, and I lead a development team at Dun & Bradstreet. How many people here have heard of Dun & Bradstreet? Oh, wow, quite a few of you. Great. So many people know of Dun & Bradstreet for the products, our credit and risk products. We produced for the finance industry. But really at the core of Dun & Bradstreet is this unique business identifier that's called the DUNS number. And our global database of businesses that contains more than 300 million unique business records and is updated 5 million times a day. So this data has a lot more value than just to the finance industry, and especially for sales and marketing use cases. So my team right now is focused on building a product called D&B Optimizer for Microsoft. And D&B Optimizer is a data management solution that provides real-time enrichment of records in Dynamics 365. And that delivers more than 80 fields of firmographic data and also continuously maintains the integrity of that data on an ongoing basis. So the way that this works is that when a user creates or updates a record in Dynamics, that data is sent to a service bus in Azure, where a series of topics and queues are used to orchestrate a chain of functions to identify the company and enrich the record back into Dynamics. So I'm going to dig a little bit deeper into this architecture in just a minute, but the data that we're processing here is sensitive information that belongs to our customers. So it's critically important that we handle this data securely. So I just want to take a couple minutes to talk about some of the technologies we use to do that. The first thing is this app service environment. This is an isolated deployment of Azure App Service that allows us to deploy our function apps into a subnet where we're able to use the security features of virtual networks to control the inbound and outbound network communications to our functions. And now that we have our functions hosted in a subnet, in a private network, we're able to lock down our Azure SQL database by fully removing public internet access and only allowing access from specific subnets of our virtual network. And that's done using these service endpoints. So like many applications, our application requires several sets of credentials in order to authenticate with other services, such as this Redis cache, our Azure SQL Server, and even our internal data service. All of these credentials are stored securely in Key Vault, and each of our function apps has a system-assigned managed identity that's used to authenticate with Key Vault using Azure Active Directory. This allows us to keep all of our credentials outside of our code. So now, as promised, I'm going to dive a little bit deeper into the architecture. So we support two relatively straightforward use cases. The first is a transactional use case where a user's actively creating or updating a record in Dynamics. The second use case is a batch use case where they already have a large number of records created in Dynamics and they want to enrich those in bulk. So the first challenge that we've had with orchestration is that this transactional and batch use cases both use the same queuing mechanism. And the problem that we have is that this doesn't scale well because these transactional operations can be delayed by large numbers of batch operations. The second challenge is that is with enrichment, or extensibility. Each of the functions in this chain is responsible for orchestrating the next step in the workflow, and that makes it difficult for us to introduce new functions into this workflow. And then lastly, these batch operations tend to be long-running processes, and our customers want to have some insight into the progress that's been made while these batch operations are running. And there's not really a great way for us to do that with the way that this is currently designed. So I just want to take a look at how we're addressing some of these challenges using durable functions. So You can see on the left side of this diagram, we've created this matching orchestrator function. This function is responsible for the order and the way that the activity functions are executed in this workflow. That means that each of our activity functions can follow the single responsibility principle, which makes it a lot easier for us to extend this workflow. For example, we've added this normalization function up at the front of the chain here to help improve our match rates. This orchestration is also dynamic now because this orchestrator can determine which activity functions to run based on input or based on results from other activity functions. This is especially useful when we introduce a breaking change into our solution and need to support multiple versions. We can do that with this orchestrator. Now, on the right side of this diagram, we've created a separate orchestrator for our bulk operations, which allows us to queue those operations independently. We're still able to make use of the logic that's used for the transactional operations. We're still able to make use of that workflow by calling sub-orchestrations of that matching orchestrator. You can see here that we've employed this fan-out and fan-in pattern where we execute several sub-orchestrations in parallel and then aggregate those results at the back end. This allows us to provide a progress update as we iterate through pages of accounts. So as you can see, durable functions can be used to solve some pretty complex orchestration challenges. We've also learned that app service environments and service endpoints allow you to secure your Azure service resources to virtual networks. And lastly, we learned that managed identities can be used to authenticate with other Azure services without any need for storing credentials in your code.
Now, that's great, Nick. Actually, before I turn your mic off, when I was talking to Nick and was talking about how his journey to serverless, he was telling me why he started on serverless. Do you mind sharing, like, how did you came about even considering serverless versus considering many other options out there?
Sure. So the event-driven nature of the serverless functions was a natural fit for the product that we were building, but also when I was assigned to this project, we had a really tight timeline to bring this product to market. So we had to do everything that we could to improve productivity, and serverless was a great way for us to do that. We didn't have to worry about capacity planning or managing servers or setting up VMs or anything like that. We're able to solely focus on writing our code and building our business value. So.
And that was with a huge team of how many developers?
One developer and one tester.
That's pretty amazing. So, so I'm talking about another case, and I love those cases, like the one Nick talked about, security, Thiago with IoT and Event Hub, IoT Hub. Makes it really simple for you to get stuff up and running. So this is another case, came out of an open hack. Thiago and I went to Brazil. We happen to be from Brazil, and don't connect to the rest of the story, but this company does payment collection. There's nothing to do with our culture there. It's just a passing comment. But and they're a software company. They sell their payment collection solution to financial institutions, to retail and whatnot, to get their payments collected. And what they do is pretty much, it's a fancy nagging system. What they do is make sure to remind people that there is a payment due at an escalation fashion. So, the payment gets more serious, escalation gets more serious, so they're more likely to complete that payment. What was interesting was, any professional nagger out there knows that you shouldn't nag person all the time by saying, have you done it, have you done it? You actually do it, and then you wait, and you do it again, because people might, emails get lost, messages get lost, so they only run their workflow about once a day. They get a set of customers, thousands of them. They send a bunch of SMS, and that software that does that goes to sleep. 24 hours later, it wakes up, nags everyone again, goes to sleep again. So they didn't want to have dedicated hardware for something that runs for a couple seconds just once a day. That just makes no sense for them to keep that infrastructure. And so what they wanted was just have that state, and what they built, and I oversimplified it here, is an orchestrator function, so it's durable functions again. How many of you are familiar with functions before I see? What about durable functions? Okay, so I'll do just quick intro durable in a second, but so what they've done is they start the durable function by checking, has this customer paid since I first read their information? If they haven't paid, let's send them a nice reminder, and then if they still haven't paid, 24 hours went by, send a more serious reminder, and then 48 hours, change the method. Now, instead of SMS, change to email. And they do this probably over 3 times. I just did simplification, I did 3 times here, but they keep reminding you different methods. And eventually, if you don't pay, in Brazil, you have this method of payment called boleto, which is just an invoice that they send to your house, and you get the printed thing, which people are more likely to take action sometimes on those. And then they send those, and you pay. And and once you pay, they thank you. If not, they truly sent you to a collections agent. I joke that I built a demo on this. I call it Repo Man. So they send a Repo Man after you. But the point being, it's super simple to accomplish this with durable function. I'll show the code in a bit. But there are other ways you could do it. So I want to just compare and contrast the ways. So some folks like building those orchestrators in a visual fashion with a workflow designer. So you can do that with Logic Apps. Tons of IT professionals love it, especially because you can connect to 200 services without learning new APIs. You can do durable functions, great if you like coding, if you have complex orchestrators, or if you want to integrate with the DevOps process out there. But some folks accomplish some of this with just functions and messaging, and they handle it with just the chaining and sort of the workflow on their own. That's possible as well. Durable functions just makes it much easier. And if you haven't seen durable, before I show the code, just show the concepts, because then make the code easier to understand. Durable functions has only three main concepts. Starter function, the one that makes your orchestrator run. The actual orchestrator that coordinates, and that one's the one that's long-lived. It's a function that essentially could run forever. And that calls into regular functions, which is our activity functions. Those run from 5 to 10 minutes. And in the diagram I had, those would be the ones that send an SMS or send an email. So those are the concepts on functions, and I'll show how the orchestrator looks like in this example. So what the orchestrator has is this orchestration trigger that you can see, and you see the function name there. And again, this is on the demo I built. I'm not supposed to show customer coding here, so I built this myself. But that's how the orchestrator looks like. And what you can read in the rest of the code is pretty much parsing input and setting up a timer. So I know if that 20, if a day has gone by, I should move to the next step on that orchestrator. This call here is the important call, is on the orchestrator, when it does a call activity async with an await clause, it actually kicks off a function, put the orchestrator to sleep. So you as a customer using durable functions, you don't pay if the orchestrator is not running. So that whole await time, you're not going to be paying for, this whole 24 hours. The orchestrator knows that either the timeout has completed, or the timer has completed, or this function wrote back to storage, which is where durable function controls state. It wakes up and continues the execution, replays the execution from the point where you stopped executing. So the orchestrator is smart that way. The actual function is just like any other function. And in functions, we have this concept of binding that makes something like send an SMS pretty simple. Most of the lines of code you see there are just configuration with Twilio, which is the service we use for sending SMS. But the code itself, all you do is you configure your SMS message, and once you return that message, the concept of a binding, we as functions platform, we run some code on their behalf that actually calls the Twilio API and sends the message for you. So what you can see here is I never had to authenticate with Twilio, understands which authentication protocol or OAuth and all that dance. All you had to do was, hey, I just have to configure my message. Functions takes care of all the rest for you. So that's my activity function. And with just these two pieces, the orchestrator and the simple functions, you can achieve that scenario that you've seen. Okay. All right. So what we learned on this one was there are different orchestrator that fits different needs. Actually, the same customers, Direct One, they did try Logic Apps as well. They just felt like their orchestration was complex, that they were more comfortable with coding and putting their code in GitHub and all that, so they went to durable functions. A lot of customers look at serverless and they feel like, okay, this is not for me because I cannot, we cannot do everything with stateless and async and short-lived. So it typically is a barrier for you to accomplish a more complex scenario, but it shouldn't be. With concepts like durable functions, you need to keep in mind that even scenarios and architectures that look complex can still be achieved with serverless. And the reason I wanted to show the simple concepts of durable is don't be intimidated. Even if you're new to functions, durable is really easy to get started. If you use the Azure portal, there are templates that you can create. Just like you create any other function, you can create a durable function right there and play with it. The takeaways from this session is, one, like serverless is really being used in production. Like the glass device, that's a real expensive thermostat, if I remember correctly, and they rely on functions and that type of architecture for their thermostats to work, right? So customers that have real hard security requirements, such as DNB, they use functions for production. So all these scenarios are there, they can be accomplished. If you're new to serverless, or if you're not used to it, we put all these links together. I don't know if I should show, but instead of you taking a picture of a slide, just get that link, run there. There is all information of all different levels, things for you to get started and advanced stuff. If you're getting started, actually, I recommend, which I might have forgotten to add there, the Microsoft Learn. There are a few modules on serverless, and you get points and badges, and you can brag that you know all about serverless. So it's fun. And yeah, and if you want to contribute and send feedback, there are some links there. Me and Thiago, we're on the social networks and trying to be cool on Twitter. So contact us and we'll try to help you out. But be successful with serverless. And thank you very much.
There's some related sessions for you to check out as well.
Oh, yeah.
Yeah. There's, like we said, there's so many different ways to use serverless for projects that we couldn't possibly cover all of them in this session. So there's a few other here that you should investigate. One that is quite interesting to me, I need to myself go and check out, is the using Azure with container instances, Azure Functions with container instances for a real project that they talked about. Also check out the Logic App sessions. They cover a few scenarios as well on how they're using Logic Apps to do the workflow between solutions. So go and check out those sessions or get in contact with us on Twitter if you want, and we can cover other scenarios as well that you can do with serverless.
Yeah, and do evaluate the session so we know if we should, do more of this. Should we bring more use cases? That's what you would like to see, more architecture and diagrams. And we'll make some of these things as we build them as demos. We'll put them on GitHub so you have something you can see, not only the reference architecture, but source code that can get you started. Thanks again.
My demo is looking like now. It's up to 26 workers behind the scenes and processing the messages pretty steadily. All right, thank you.